Good evening, sir.
Hello, everybody. Good evening, Krishma. How are you? Hello, Assalamu alaikum. Hiba,
Good evening, sir.
Fine,
good
sir.
evening. I'm fine, dear. Thanks so much for asking. What about rest of you, Jobita, Abhi, and Shweta?
Hi, sir.
Hello, how are you, Bache?
Good, sir. How are you?
I'm fine, dear. Thank you so much for asking. So, as you know that the revision series has been started. So, this is our first class of the physics revision. Okay. So, we'll be having two class of physics in a week for the revisions.
Okay, sir.
Yeah. So, so first chapter that we'll be doing as the in the revision classes will be light chapter. Okay. Okay.
Yes, sir.
Just wait for 2 minutes so that the remaining students can also join. Hello, Samina. Assalamu alaikum. How are you, dear?
I'm fine, sir. What about you?
I'm fine, dear. Thank you so much for asking. Okay, so let's start the class. Okay, so I think that most of the students have joined. Okay, so let's start the class without any delay. Okay, so first of all, this chapter is basically that currently we are doing is the light chapter as the first chapter. Okay, so first, yeah. So let's understand. Let me check how. Hello, Abdullah. Assalamu alaikum. Are you there, bache?
Walaikum Assalam, sir. Yes, sir.
How are you?
I'm fine, sir. Thank you. What about you?
Alhamdulillah, I'm fine as well. So revision classes start away. So one more thing, everybody, is that from the next class onwards, you are requested to revise the concepts of this chapter. Okay. So that because revision is going on, so we'll be doing very crisp theory and some numer and the PYQs. So that's why it's requested to basically to revise the concepts from your notes. Okay.
Yes, sir.
Yeah. Okay, so let's start the class. Basically, this chapter is basically based on the two phenomena, that is reflection and refraction. So reflection is, let's understand what is reflection. I'm just basically I'll be making some short points on the reflection. First is reflection. Reflection is the bouncing bouncing back of light from a polished surface into the same medium. Yes or no, everybody?
Yes, sir. Yes, sir.
Into the same medium. Okay, so basically so reflection has two types of two laws basically. For so first law is
The angle of incidence is always equal to angle of
law of
reflection.
reflection. Very good. The angle of is equal to angle of basically reflection. Second law is the incident ray. Very good.
And lie on the same plane.
Incident ray, reflected ray, and normal all lie in the same plane. Okay. So these are the all lie in the same plane. So these are the two laws of the reflection. Okay. And one more thing is that two types of reflections are there. One is a regular reflection that we'll be studying, and one is irregular or diffused reflection. Okay. So let me tell you how you will basically how does it look like. So suppose this is the incident ray. This is the reflected ray. And this is the normal that is perpendicular. So basically this angle I, and this angle, that is angle R, are equal to each other. So this is this reflection in which you can see this thing, you can predict. Suppose that one more incident ray is there which is parallel. Which is parallel to this. So you can see this thing. If this is parallel, so the incident ray will be parallel, or the reflected ray will be parallel to this one. Yes or no? As you can see, this is called regular reflection, in which the direction of ray, the path of ray can be predicted. And for the basically the normal for this ray will be this. Just a second. There, everybody?
Yes, sir. Yes, sir.
I hope it's clear to you. Any doubt regarding this concept?
No, sir.
No,
Sure,
sir.
very good. Okay, let's talk about the another case, that is irregular reflection. And let me make a diffused, you can say, so like this. So you can see this thing. If you draw, if the ray is incidenting, and this is the normal, and this is the normal. So you can see this thing. The ray is incidenting on this surface. This is not even. So the reflected ray is not predicted in which direction it will go. Okay. And suppose if a parallel ray is introduced here, so you can see this thing, this ray is parallel, but the reflected ray will not be, suppose it can go like this. Reflected, is this, are these rays parallel to each other?
No.
No, no.
No.
So it means that these will be, so you can see this thing. So this is not predictable. So that's why so we will be basically dealing with these regular reflection. Okay, everybody?
Yes, sir.
Okay, very good. So let's understand. Okay, so let's understand the concept of image. The two types of images are there. That is, first one is virtual and the second one is real. So this is one of the most common question in the school exams of 3 marker, that differentiate between real and virtual image. Okay. So first is real image. And it is virtual image. The real image is basically, it can be obtained on screen. Okay. Real image can be obtained on screen. Okay. Virtual image cannot be. Okay. Virtual image can't be obtained on screen. And real image is formed by the actual intersection of at least two rays. Okay. Real image is formed by actual intersection or meeting of two rays. Virtual image is formed when we assume that these two rays will be basically meeting at behind the mirror or somewhere else. Okay. Formed by extending rays in the backward direction. Backward direction and assumed to be intersecting. Assumed to meet. ठीक है. Real image is inverted. Yeah. Virtual image is erect. Okay, everybody, got it?
Yes, sir.
Any doubt to anybody, please let me know.
No, sir.
No, sir. No, sir.
Okay, that's great. So these are the three basic differences between real image and virtual image. This can be a 3-marker question that differentiate between real image and virtual image, and with some examples. So example will be nothing but simple. The image formed by an eye is a real image, yes or no? Because rays actually meets at the retina. Yes or no?
Yes, sir. Yes, sir.
Okay. So example says uh, formed at retina. Next example is, you can say you have suppose you have seen this thing, a mirror in the convex mirror is basically forms a virtual image. Clear? Or you can say image formed by plane mirror is also virtual. So this is an example of the virtual image. Okay.
Yes, sir.
Yes, sir.
Image formed in plane mirror. Clear, everybody? So this is a very basic difference. These are the very basic differences between virtual and real image. And this is a very hot topic that can be asked in the school exams and the boards as well. Okay? So be, you can say, don't skip it while revising. Okay? So next is, so basically now we are done with this topic. So basically now let's understand the type of now let's get in dive into the spherical mirrors. Okay, so basically reflection, we have seen this thing. चलो मैं पहले वो बता देता हूँ आपको, plane mirror बता देता हूँ. Okay, plane mirror. So plane mirror, we have already seen this thing. So first type, basically two types of mirror are there. First is plane mirror. Types of mirrors. The first one is plane mirror. Second is spherical mirror. And in spherical mirrors, there are more two types, which is convex and concave. So basically, let's understand the first one, that is plane mirror. So plane mirror. So basically, plane mirror forms a virtual and erect image. Suppose that this is a plane mirror in front of you and you are standing. Just a moment. Okay, so this is a plane mirror. Basically, this is the covered side, and you are standing right there in front of a plane mirror. Okay. So basically, plane mirror forms the same height of image at the same distance from the mirror. Okay. Everybody, yes or no? Please let me know, is this clear to you or not?
Yes, sir.
Okay. The image, this distance, and this distance is same. So that is u and that is v. Okay. So and one more thing, how you will show this thing, that this ray, this path, it basically retracts. So we need at least two rays to draw the diagram. Okay. If we extend this one, so this will straight directly go there, and this ray will just directly meet there, like this. This is how the image formation is image is formed of this. Yes or no, everybody? Please let me know if this is clear or not. This is height of image, sorry, height of object, and this is height of image. Clear?
Yes, sir.
Because
Yes.
this basically we need two rays. So one ray that is parallel to this basically your surface, and another ray is basically following the law of reflection. If the angle incident is I, so it will be reflected by our angle, and both the angles will be same. So that's why if you extend this point in the backward direction, so these are the assumed to be meet. You are just assuming that they are going to meet in the backward behind the mirror. Yes or no? Yes or no?
Yes. Yes.
Okay, so first part is that is basically, so understanding the plane mirror characteristics is basically a plane mirror forms virtual and erect image. Second point is plane mirror forms image of same size of the object. Yes or no? Have you seen that you are standing right in front of the mirror, and your hands hands are looking very longer and bigger? Is it possible?
No, sir.
Ah, same size of the object. Clear? Next is magnification of plane mirror is 1. What is basically magnification? Magnification is the ratio of V by U, and there is a negative sign in the mirrors. Just a second, it's negative in the हाँ negative होता है mirror पे. Mirrors में negative होता है actually, just a little bit. Minus of V by U. ठीक है? Yes or no, everybody? Please let me know.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Yeah. एंड वन मोर थिंग इज दैट बेसिकली, चलो मैं अभी बता देता हूँ अभी। तो इसकी जो मैग्निफिकेशन होती है प्लेन मिरर की, वो 1 होती है। वाई? लेट मी टेल यू दी, आपको मैं यहाँ पे साइन कन्वेंशन बता देता हूँ। लेट मी टेल यू साइन कन्वेंशन। इसको चलो ठीक है। So basically ये एक new sign, basically this is new sign of convention. This is the direction of light. Everybody please note it down in your notebooks as well, the thing that I'm drawing. This is a very important, okay? Direction of light is in the rightward direction, so it will be considered as positive. Okay, yes or no? Okay, and this is the basically the pole of any mirror. This is focus. This is center of curvature. Okay, and the direction, basically the distance is measured from pole. In either of the direction, if you are going in the leftward direction, you will be starting from the pole towards this side. If suppose that this is origin, if you're standing at the origin, you will go start from the origin, whether you are going in the left or in the right direction, yes or no?
Yes,
At least
sir.
yes or no. So if the yeah, so you see, just assume, see this thing that the light direction is in the rightward direction, but you are going in the opposite direction of light. So it means that this will be considered as negative, yes or no?
Yes, Yes, sir.
Any doubt to anybody, please let me know.
No, sir.
Next, and if you go in the rightwards direction, that is in the direction of motion, in the direction of light, it will be positive, yes or no?
Yes, sir.
This
Yes.
basically, this pole is nothing but it's a kind of origin for the ray diagrams and for the you can say the sign convention for the ray optics. Okay.
Yes.
Okay. And next thing is, if you go basically in the upwards direction from the pole, just like this, suppose that you're basically you're standing right directly. So this will be positive. Okay. And if you go downwards the pole, that will be negative. You can see this thing that this is very similar to the origin concept in the coordinate geometry in the 9th class. Even in the, you can say this, you can say, I think, हाँ 9th class में था, like I think coordinate geometry 10th class में जो उसमें ये concept ये वाला नहीं है. But in the 9th class you have already plotted this thing. So is it clear to you or not?
Yes, sir.
Any doubt to anybody? Please let me know. Be honest with me. Anybody having any doubt? Yes or no?
No, sir.
Clear?
No, sir.
Got it? How you will calculate and measure the distances?
Yes, sir.
Okay, that's great. So this is all about the plane mirror. Okay, so let's understand this spherical mirror concepts. Spherical mirror. First one is concave mirror. That is like this. They go just like this a little bit. Like this. The concave mirror is like this. The outer part is covered, or you can say curved. Okay, and the inner part is not covered. This is a concave mirror. Okay. So and this is the, you can say, one more thing. This line is called principal axis. Principal axis. Okay. So basically for this, you can see this thing, the intersection point here will be called as this pole. Yes or no, everybody?
Yes, sir.
This is
Yes,
the
sir.
focus and this is the center of curvature. Okay. So basically the concave mirror has the characteristic that it will be forming a real image except in one case. Clear? And one more thing, it's also called converging mirror. Converging means that it will Suppose that thing, suppose your object is basically right there. Okay, object is basically placed right here. So this ray will go, first ray should be parallel to the principal axis. That basically this is the most common way of basically drawing a ray diagram, is that first you at least you need two rays. You need two rays to form a ray to draw a ray diagram. First ray should be parallel to the principal axis. Okay, at least yes or no.
Yes, sir.
Yes.
Yes, sir.
If this is parallel, it means that it will pass through the focus.
Yes.
Yes, sir.
And the second ray
Pass through the curvature.
pass through the curvature, or you can see this thing pass through the
Pass through
focus,
the
and it will
focus.
get parallel to the circle, or it will be parallel. There are so many you can say possibilities, so you can take any two possibilities. Okay, just a second. Thoda sa. Actually, I'm using a rough-handedly drawing, so that's why a little bit asymmetry is there. So pardon me for that. So this image will be basically beyond the curvature. Okay, size is already bigger, but it will be beyond a curvature. Actually, basically, I'm using raw rough-handed diagram. So pardon me for the asymmetry in the diagram. Okay, so you can see this thing. It means converging means you can see this thing. If the ray is going parallel, if it strikes on the concave mirror, it is converging. It basically merging. Converge means a kind of, you can say, if two things are going and they are going to meet, it means there will be something is basically trying to meet them, merge them. It will be called as converging. Okay, converging. Okay, got it? Yes or no?
Yes.
Suppose this
Yes,
thing,
sir.
these two rays are there and they are point, and at some point due to some object or something, that object will be called as converging object, which basically tries to converge them at a common point. Okay,
Yes.
yes or no? Yeah.
Yes,
So
sir.
that's why it is called as converging mirror. Okay, so first property of concave mirror is concave mirror is a converging mirror. Okay, second property, concave mirror focal length is negative. You can see this thing, pole is there, so focal length, focus is there on this principal axis. You are going from pole to focus, but the direction of motion light is in this direction. You are going against the motion of light. It will be negative. Yes or no, everybody?
Yes, sir.
Yes, sir.
Okay. Concave mirror always form real images. Real image except one case. In only one case, it will not it will not form real image. It will form virtual image. Okay. Concave mirror is used in torch lights, headlamps of automobiles, okay, etc. So okay, everybody, please let me know if this is clear to you or not.
Yes, sir.
Okay. Okay, so opposite to this, one is convex mirror. Okay. One is convex mirror, that is opposite of the concave mirror. The bulgy part is outside. Inner part is covered. Okay. The light reflects on the outer surface. Okay, everybody?
Yes, sir.
Yeah. And this is the principal axis. Okay. And basic, and one more thing, concave mirror have I think 5 or 6 cases. It's just a second. Infinity for beyond curvature, and between curvature at focus. 6 cases. 6 cases will be there. Okay, but in the convex mirror, only 2 cases are there. Okay, one is at focus, and another with that, another is at the basically between. Sorry, first one is at the infinity, and second one is the between the infinity and the center of, well, basically pole of the mirror. Okay, so it is called one more thing. It is called diverging mirror. Basically, it diverges the rays. It basically spreads out the rays. Okay, diverging. Yes or no, everybody?
Yes, sir.
Yes.
Diverging mirror. Okay. And one more thing, can anybody tell me where should be the focus? How to identify whether the focus will be on the left hand side or on the right hand side? How you will identify it? Let me know. Basically, you will take that point as focus where the rays actually meet. You can see this thing now. This is a focus. It means that the focal length will be negative. Clear? But if you take this thing, suppose that if you have one, basically you are standing here. Okay, suppose you are standing here. Okay. And the first ray should be parallel. Yes or no?
Yes, sir.
But it will spread it out. Okay. And the another ray, it should go from the, it, it should go or you can say for it, you should take this ray as the pole ray. You can see this thing now. If you basically extend this line a little bit, okay. Yeah, see this thing, that image is forming on the right hand side. Yes or no?
Yes, sir.
So image is forming on the right hand side. It means that focus will be on the right hand side.
Yes.
Everybody, please let me know once. Is this clear or not?
Yes, sir.
Okay. So, so basically this is F. Okay. So that's why it is called diverging mirror, because it spreads out the light rays. Okay. So that's why it's called diverging. I think you must have seen one basically diversion ahead, work is in progress. You must have seen this on the roads when the work is going on, when the construction work is going on the road. Diversion ahead. It means that it spreads out the road into different subsequent parts. Okay.
Yes, sir.
So that's why. So let's talk about the basically the convex lens. Oh, sorry, convex mirror. First is convex mirror always form virtual image, virtual and erect. Focal length of convex mirror is positive. is positive. Clear, everybody?
Yes, sir.
Okay, one more thing. And the third part is instead of third part is convex mirror is used in rear view mirror. You have seen rear view mirror in the cars, side mirrors, and street lamps, etc. Okay. Okay, got it, everybody? Yes or no?
Yes.
Any doubt?
No, sir. No, sir.
Sure.
Yes, sir. Yes.
Okay. So that is the basically the characteristics of the convex mirror and concave mirror. Okay. And now let's talk about the mirror formula. Mirror formula is, can anybody tell me what is mirror formula?
1 by F equal
1
to
by
1
V
by
plus
1 by U.
Okay, very good. Very good. 1 by U plus 1 by U, 1 by V plus 1 by U is equals to 1 by F. What is V here? U is
image
basically,
distance.
yes, very good. What is U here?
Object distance.
Object distance. What is F here?
Focal length.
Focal length. So object distance from pole. Always remember it is from the pole, okay? From pole. Okay, got it, everybody?
Yes.
Yes.
Just give me a moment. Let's do some basic PYQs on the basis of the mirror formula. Just allow me a moment. Any doubt? Anybody, please let me know.
No, sir.
Sure.
Yes, sir.
Okay, that's great. Okay. Let's do this question. It's recent. It's a very recent question. It's asked in CPC 2017. Just give me a second. Let me paste it right there. Who is there? Okay, Shaima, please send that out on the official number. No worries, dear. We'll solve it together. And one more thing is that. Okay, dear. I got it. Let me check. Okay, So Shaima, basically, dear, this is a refraction doubt. In the next class, we'll be doing the refraction. So we'll be taking this doubt. Okay, don't worry. Okay. Because right now we are covering the this reflection part now. Yeah, so we'll be doing that in the next class. In the upcoming class, we'll be doing the refraction part. So we'll be covering that thing. Don't worry about it. Okay. I have downloaded the figure. So we'll discuss it in the next class. One more thing is that there is one formula of magnification, that is minus of v by u is basically magnification gives you the idea how much basically what is the ratio of the image and the object, ratio of the object distance and image distance to give you how much the magnification is. Is it enlarged? Is it diminished? Or is it of the same size? Okay. And the negative sign shows that is it virtual or erect. Clear, everybody? Negative signs means real and inverted. Positive signs means basically if the answer is so just a second, let me tell you. M is negative, means that real and inverted. Okay. M is positive, virtual and erect. Clear? Yes or no?
Yes,
Please
sir.
let me know. Okay. And one more thing, the formula is also this HI by HO. Okay. Let's do this question. So first of all, the question is saying that an object of height say 4 centimeter. So what will be it will be negative or positive height of an object?
Positive.
Positive, very good. Because it's above the principal axis. Is placed at a distance of 15 centimeter in front of a concave mirror. So what will be the u? U will be negative or positive?
Negative.
Negative.
Negative, minus 15 of centimeter. Okay, and the focal length of the concave mirror is given, that is 10 centimeter. Okay, one more thing, just remember one thing. Whenever the concave word is used, focal length will always be negative. Whether it is concave lens or mirror. Clear, everybody?
Yes, sir.
Okay. And convex word is used whether it is lens or mirror, focal length will be positive. Just remember this thing. If you got confused whenever, like suppose that you are having some trouble while finding that it is negative or positive, just remember this thing. Whether if the concave word is used, it means that focal length will be negative. If the convex word is used, it will be positive. Okay. So it means that minus of 10 centimeter will be the focal length. We have to find out the image distance of the object and what is the height of the object as well. Okay, so let's find it out applying the mirror formula, that is 1 by V 1 plus 1 by U is equals to 1 by F. So 1 by F is 1 minus 1 by 10 is equals to minus, sorry, 1 by U V है ना, V निकालना है हमने, 1 by V minus of 1 by 15, taking 1 by 15 on the right hand side. The most simplest way of doing this, just basically cross multiply them. Cross multiply them means 10 will get multiplied with this one, 15 will get multiplied with this one, and the denominator will get multiplied by each other. 15 into 10, 10 minus 15. Why did I did that? Basically, I just wanted to basically remove and eliminate without any complex calculation. That's why I've done this. So minus of 5 divided by 15 into 10. If I have taken LCM and all the things, so that will be a cumbersome process. Instead of that, I have just took the cross multiplication part. So just it would get divided by 3 times. So 1 by V is equals to minus of 1 by 30. So V is equals to minus of 30 centimeter. It means that we are correct because a concave mirror forms the object on the same side of the mirror. Clear?
Yes, sir.
Any doubt to anybody? Please let me know.
No, sir.
Okay, let's find out the height of the object. So basically you can see this thing, magnification is equals to minus V by U is equals to HI by HO. So you can see this thing, minus of V is minus of 30 divided by minus of 15 is equals to HI is not given, divided by 4. Okay, so you can see this thing, negative will get cancelled this negative, but one negative is left. So 4 minus of 2 times and 4 will get multiplied with minus of 2. So it would be minus of 8 centimeter. It means that the image is getting enlarged. You can see this thing
Yes,
because the object is 4 centimeter, but the image is 8 centimeter. Negative sign shows that the image is inverted. Clear, everybody? Please let me know.
yes, sir.
Any doubt to anybody? Please let me know.
No,
No,
sir.
sir.
Sure.
Yes, sir.
Yes, sir.
Okay. So let me take one more question. We have 3 minutes more. Just allow me a moment. Hello? Can you check who's that? Please mute yourself, Manisha. Convex mirror doesn't have so many numericals. I'm just not able to find it down. Just allow me a minute. Well, I don't think so that so like in the like for the convex mirror there are very less numerical. So based on the concave mirror is much more than that. Okay, so in the next class we'll be doing some numericals. Okay. Okay, one question is there, which is objective type question directly, and please let me know the answer. So 1 or 2 numericals we'll be doing in the next class, and we'll be doing the refraction part, and this chapter will be done. Okay. So please let me know which is the correct answer.
Option either plane or convex.
Who gave the answer? Please let me know your name.
Sir Abir.
Okay, dear.
Sir, option 1.
Okay, option 1 by whom?
Sir, Shaima.
Shaima. Okay, dear. What about rest of you? Everybody, Karishma, Hiba, and
Sir, option
Option
4.
4.
Sir, 4.
Sir plane mirror.
okay, Samina said plane mirror. Okay,
Plain and convex.
plane convex. Okay, okay, okay. Okay, so basically the correct option is the plane and convex, because it's saying that no matter how far you stand from a mirror, your image appears erect. Oh, I've written this thing right there in the convex mirror. Always form virtual and erect. Plane mirror always form virtual and erect. Along with the plane mirror, convex mirror is also a mirror that always form virtual image. Clear, everybody?
Yes.
Yes, sir.
Any doubt to anybody?
No,
Because
sir.
if you say
No,
only
sir.
plane, if you say only plane, this is an insult for the convex. Convex will say, I'm also able to form the virtual images. Why are you not including me? Okay. So you have to give respect to both of the mirrors. Okay. That is plane and convex. Okay, everybody?
Yes, sir.
Yes,
So
sir.
yeah, got it.
Yes, sir.
I hope
Yes,
it's
sir.
clear to everybody that we have covered so far, we have covered so far